A beam 3 meter long has rectangular section of 80 mm width and 120 mm depth. If the beam is carrying a uniformly distributed load of 10 kN per meter, find the minimum bending stress developed in the beam. So here there is a beam of rectangular cross section and its width B is equals to 80 mm, width of the beam is 80 mm, and the depth of the beam D is equal to 120 mm. So width of the beam, width and depth are given. Width W is equals to, or B is equals to 80 mm, B for width, and D for depth. Depth is equals to 120 mm. Depth is equals to 120 mm. Okay, is subjected to UDL load, uniformly distributed load. This beam is subjected to UDL load. Okay, so UDL load small w equal to 10 kilonewton per meters. We know that 1 kilonewton per meter is equal to Newton per mm, 10 Newton per mm. Okay, so UDL load is given. Next, here we have to find maximum bending stress developed in the beam. Maximum bending stress. Maximum bending stress. Okay, developed in the beam. So maximum bending stress sigma B max is equal to question mark. Okay, so given beam is rectangular beam. So this beam is having rectangular cross section and width is given and depth is given, and this beam is subjected to UDL load, uniformly distributed load. Okay, since beam is subjected to uniformly distributed load, maximum bending moment in case of rectangular beam subjected to UDL load, maximum bending moment M is equals to W L square by 8. W L square by 8. Okay, so here W means UDL load and L means length of the beam. So in this question, length of the beam how much? Length of the beam. So length of the beam L is equals to 3 meters. 3 meters means 3000 millimeters. 1 meter is equal to 1000 mm. 3 meters means 3000 millimeters. So maximum bending moment WL square by 8. Okay, so here we have to find maximum bending moment. So now M is equal to W how much? W 10 into L square, 3000 whole square by 8. 10 into 3000 whole square. So 3000 whole square means 3 square 9 into 3 zeros. Okay, na 10 cube whole square means 10 power 6 by 8. It can be written as 9 by 8 into 10 into 10 power 6, 10 power 7. So bending moment unit Newton mm. Okay, so we need maximum bending stress. Now according to theory of simple bending, M by I is equals to sigma B by Y is equals to E by R. Okay, so let us consider M by I is equal to sigma B by Y. So from this equation, sigma B is equal to what? Sigma B is equal to M by I into Y. Here M means bending moment, I means moment of inertia, Y means distance from neutral axis to the outer layer. So anyhow, it can be rewritten as M by I divided by Y. I by Y means what? Ratio of I and Y is called section modulus Z. Section modulus Z. So what is the formula for bending stress? So bending stress is equals to bending moment by section modulus. Okay, so in case of rectangular cross section or rectangular beam, section modulus formula BD square by 6. Okay, na? Formula for section modulus in case of rectangular cross section or rectangular beam. For rectangular beam, section modulus formula BD square by 6, Z equal to BD square by 6. Okay. Now we need maximum bending moment sigma B. Now find section modulus. Z is equals to B value. B how much? 80. D square. D how much? 120 whole square by 6. 80 into 120 whole square means 144 into 12 square, 144 into 10 square by 6. Okay. So 2 3s, 2 40s. And 3 how many times? 144. 3 1s, 3 4s, 12 and 8s. Okay. So you will get Z is equals to 40 into 48 into 10 square, okay, mm cube. Now bending stress sigma B is equal to maximum bending stress. We want maximum bending stress is equals to m how much? 9 by 8 into 10 power 7 by Z 40 into 48 into 10 square. Okay. Now 9 into 10 power 7 by 8, denominator 8 into 40 into 48 into 10 square. So here 10 square in here 10 square can cancel, and the remaining sigma B maximum is equals to maximum bending stress is equals to 9 into, so 10 square means still we have 10 power 5 by 8 into 40 into 48. Okay. Now 3 3s are and 3 16s are 48. So 3 into 10 power 5 by 8 into 40 into 16. So 3 into 10 to the power of 5, 3 into 10 to the power of 5 means 1 after how many zeros? 1 lakh. Okay. By 8 into 40 and 40 into 16 means 5120. So 3 lakhs by 5120. So if you calculate, you will get approximately its value as 58.6 Newton per mm square, or 58.6 MPa. MPa means mega pascal. So maximum bending stress in the rectangular beam is 58.6 MPa, mega pascals. This is the final answer. A rectangular beam 200 mm deep is simply supported over a beam of span 2 meters. Find the uniformly distributed load the beam can carry. If the bending stress is not to exceed 30 MPa, take I for the beam as 8 into 10 to the power of 6 mm power 4. So there is a rectangular beam of 200 mm deep. So 200 mm deep means D is equal to, depth is equals to 200 mm, and he also given span means length. So here length of the rectangular beam L is equals to how many meters? 2 meters. Okay, so 2 meters means how many millimeters? 2000 millimeters. Length is equal to 2000 millimeters, and depth D is equals to 200 mm, and also he given maximum bending stress. Maximum bending stress. Maximum bending stress. So in this question, maximum bending stress sigma B max is equals to 30 MPa. And also given moment of inertia, I is equal to, take I as 8 into 10 to the power 6 mm power 4. Okay, so at last we have to find uniformly distributed load. Okay, this rectangular beam carry a uniformly distributed load, so W we have to find, W in Newton per mm. So we need UDL load, uniformly distributed load. Okay, we are going to use two formulas. First formula is when a simply supported beam carries a uniformly distributed load, then maximum bending moment. In case of simply supported beam, maximum bending moment WL square by 8. When a simply supported beam carries a uniformly distributed load, then maximum bending moment at center is equals to WL square by 8. And also according to theory of simple bending equation, M by I equal to sigma B by Y is equal to E by R. Okay, so let us consider bending moment equation. Sigma B is equal to what? In bending moment equation, sigma B is equal to M by I into Y. M by I into Y. So M is equal to W L square by 8 into I into Y. Okay, na? So M means maximum bending moment. Sigma B is equals to W into L square by 8 into I. So what is Y? Y means what? Y means distance from neutral axis to the outermost layer. So Y is equal to, in case of rectangular beam, Y is equal to D by 2, half of the depth of the beam. Okay, distance from neutral axis to the outer layer. So total distance how much? D. Total depth is D equal to 200 mm. So half of the depth is called Y. So here Y means D by 2. So W L square D by 8 2s are 16. 16 I. 16 I. Next, let us simplify further. Sigma B means how much? Sigma B how much again? 30 is equal to W. We don't know UDL. We have to find UDL. L square 2000 whole square into depth. Depth how much? 200 by 16 into moment of inertia 8 into 10 to the power of 6. 30 is equal to W into, so 2000 whole square means 2 square 4 into 3 zeros whole square means 10 power 6 into 200 by 16 into 8 into 10 to the power 6. So 10 to the power 6, 10 to the power 6 cancel. 4 1s are 4 4s are. Okay, again 4 1s 4 50s. 30 is equal to W into 50 by 8. Now transpose 8. 8 into 30 how much? 240. 240 is equal to W into 50. So 0 0 get cancelled. Now UDL W, uniformly distributed load, W equal to 24 by 5. Now calculate 24 by 5. 24 by 5 how much? Okay, 4.8 Newton per mm. Okay, so therefore UDL load is so uniformly distributed load is W equal to 4.8 Newton per mm. So this is the final answer.